Today we're looking at line of best fit. We started looking at this the past couple of days where we plotted points and we tried to come up with an equation that fits the data best. So we're going to look at it a little bit more in depth today. Number 1 says plot the following points on the grid below. Label the axes. Let X represent total fat in grams and Y represent the total calories. So we have total fat is going to be on the X, total calories on the Y. So what do we need to go up to on the X-axis?
20, 31, 34. 34, 34.
All right, so
Let's go for 5.
5s. Okay. And on the Y-axis,
We need to go
590, I think.
yeah, up to 590.
We can go about 10.
Can we?
But we could start at.
We could start at 500 and
No,
go
we
up.
start at 200.
Well, actually, we were talking about this earlier.
Can we do a break at the beginning and in the middle?
No.
Oh.
We looked at, even if we started at 200, we probably wouldn't be able to break it down much smaller than 50s. So 5th hour, we just decided to do increments of 50. So if you wanted to, you could do the break and see if it works for you, but we'd still have to go from 200 to 600, and you're trying to, the point of the break is to make it, the scale smaller and a little bit more accurate, and it didn't really work for us in 5th hour. So if you want to try it, you're more than welcome to. But what we've done is we've done increments of 50 and gone up to 600. All right, so your first point is going to be where?
9 and 260.
Okay, so plot that point.
Can you all step up? Thank you.
No, only girls that are going to J.
All right, so 9 and 260, and then what's the next point?
13 and 320.
All right, plot that one. Go ahead and do the rest of them.
Oh my god.
No, I'm sorry. We're just here.
Valentine's goodies.
You're welcome.
I wish I was low. I wish I was low.
Just read nothing.
Oh well, I have.
Me. I was like,
My dad bought me a giant box of chocolate. Like it's literally.
My dad bought me some earrings.
And I got lottery tickets and I won $20. So I'm a winner.
Warren, be quiet.
No, Connor. Shut up. I'm not even paying attention to what I'm doing. Connor?
Quiet.
No.
Both of you need to stop.
What?
Alright, do we have all of our points
Yeah.
plotted?
Yep.
Okay, so does it look something like this?
Similar.
Similar? Okay. And looks something like that? Alright, why don't we want our points connected?
Scatter plot.
It's a scatter plot. So we want to put the data where it falls, see what happens. Now, on the back, it asks us to draw in a straight line that would best fit the data. So we're looking for a line that runs through the data, hits a couple of points. You'll have some above the line, some below. You're not going to hit all the points. So you're looking for, this is what we call the line of best fit.
I have an idea.
Do you?
Yes.
Awesome.
Should go like right in the middle.
Oh, I love that.
Now you go in the corner.
Now, what difficulties are we having with putting our points on this graph paper here?
What?
It's not exact because it's increments of 50, so it's harder.
So
Right.
it's kind of like where we think it is.
Right. All right, so drawing a line there. On the back it says, 1 point I choose. We're looking at 2 points that are on our drawn line. 1 point I chooses and the second point I chooses. So I'm looking for points, one down towards the beginning of the line and one towards the end of the line. So the points that I'm looking at are 9 and 260. And I'm also looking at 31 and 560. Once I choose 2 points, what is this going to help me do?
Figure out the slope.
Slope? Yep.
Yeah, that.
All right, so number 4 asks us to calculate the slope of the line.
So it's changing y, which is 9.
Correct. So I have 9 and 260, and I have 31 and 560. So my change in y is what?
300.
300. And my change in x is
22.
22.
Wait, really?
Would you want to reduce that?
Yes.
Okay.
So on this, do 300 divided by 22, and we'll look for.
150 over 11.
No.
Yes, it is 150 over 11. Take 150 and divide it by 11. Tell me what you get.
You would get it decimally.
Yes. 13 point. Okay. All right. So what's the other thing that we need in order to write our equation?
The y-axis.
The y-intercept.
Y-intercept.
Yeah.
All right. We could do it 2 different ways. We could look and see where it's hitting on the front. We could use the point slope form to be a little bit more accurate by using these points that we're using for our slope. So if I use point slope, I need y minus, what's my y1 value?
Y minus 260. No, wait.
Equals,
260 equals 13.63
times x minus,
minus 9.
okay? Y minus 260 equals 13.63x minus
Negative 122 plus 67.
okay?
So it's an addition.
Oh, never mind.
No, wait.
There's
Yeah.
just one negative sign there. Now I add 260 to both sides. So my equation is y equals 13.63x plus,
137.
okay? 137. So what is our y-intercept?
157.
Does this point make sense? If you look at the data on the other side, does it look like it falls reasonably within, somewhat close to our line? Okay. Let's look at the equation that we just came up with and compare it to our data points. So we have y equals 13.63x plus 137. What do you think? Does that line look good?
Yeah.
Would you want to change it at all?
No.
If we change our slope to 16, what do you think is going to happen?
You
with the
want
line?
to see
It's gonna get steeper.
It's going to get steeper? Thank you, Annie. It's going to get steeper. You're right.
Another sucker for the win.
Good. All right, so that one does look like it fits pretty well. 13.63.
Teachers and students, please excuse the interruption. All freshmen and JV girls basketball members are excused for the day. Thank you.
Good luck, Chelsea. Because she had to go see the trainer. All right, so what you want, this is what you want when you're doing a line of best fit. You want your line to hit a couple of points. We could have probably put in a little bit steeper slope and it still would have been a decent line. You want to hit a couple of points along the way. You want to have some above the line, some below the line. Because when it falls more towards the middle, that's a better representation of your data. So, are we always going to have exactly the same lines? No, we probably won't. We'll have something that's close. See ya. Chelsea. Chelsea.
Don't lose.
Is there one perfect line that's going to fit our data the best?
Probably.
No, because
what'd you say?
it's scatter plots.
It's a scatter plot. So there's not really going to be one line that fits the best. We've been looking at this all day and I've come up with different equations for each different class. So it's okay that they're a little bit different. Number 7. This equation may now be used to predict information that was not plotted in the scatter plot. Predict the number of calories based upon 22 grams of fat. What are we asked to find? Number of calories. Okay. And the number of calories is represented by which axis?
The
The Y.
Y.
X or Y?
Y.
Okay. So this is represented on the Y. And we're given 22 grams of fat. And that's represented by which axis?
X.
X. So what are we going to do with these two things here?
You will do Y the 2.
I'm going to use our, it says to use the equation. So what am I going to do with these, the equation?
Insert them into our equation.
Okay. So Y equals, we're looking for the number of calories, so we have the Y there in place of the number of calories.
Y equals.
Or I guess you just guess, like I guess 498.
And how did you guess?
Well, I went to 22 grams of fat and then did exactly up where the line met. And
Okay, that's good. But we were told to use our equation.
So Y equals to the X.
So we're going to use the equation, but that is another way to use the graph. It's a great way. Y equals 13.63.
X plus.
But I thought I was
Y2.
putting something in place of.
Do we need our book for our homework?
No. I thought I was putting something in place of the X. The 22.
Oh, okay, so you just do that.
So you just times them.
13.63 times 22 plus 137. So I've substituted the 22 in for the X. So what does that give me? 436.8. All right, I'll round it up to 437. Connor, how many did you come up with when you looked at the
For
graph?
the A,
Yes.
I got 490.
Okay.
What
Our equation gave us 437.
I got like 430.
Okay. So 437 represents what
Oh.
units?
Yeah, I got like
437 grams.
I'll remember. Looked at 25.
Oh wait, we're doing calories.
Wait,
so it
yes.
would be-
It's the other way around.
I got 20.
437 are what units?
Oh,
Round calories.
Thank you.
Huh.
Oh, so that one, okay.
I just got really high.
Alright, predict the grams of fat based upon 400 calories.
So switch.
So it'd be the opposite.
Okay,
So
I need to find the grams of fat. What letter is that represented by?
X.
X. And 400 calories represented by? So I put the 400 in place of the Y.
So it'd be 400.
Was
13.63x
Plus.
plus 437. Wait, wouldn't it be?
No, because that's the other equation. That has nothing to do.
Oh, okay.
This is our equation.
Okay.
We're starting with the basic equation. Doesn't matter what we got out the last time. So now what do we need to do? Bless you.
We solve it.
Okay, how am I going to solve it?
You add 13.63 plus 1.
No,
No,
you
add
add
one.
one or subtract 137.
Yeah, that's what I meant.
Subtract 137. So 400 minus 137.
So it'd be
263 equals 13.63x.
Is that, I think that's.
yeah.
Then you.
What do I do now?
You divide by 13.63.
Is this
So-
gonna be on the test?
X equals,
we don't have tests this week. Or did you lie to me? Or am I lying?
Oh wait, no, that says
You don't have a test.
ag 2.
19.29. What are my units?
Grams.